and advanced metal products. Company headquarters are located at this main plant at Lindbergh Field, San Diego, which covers 54 acres and contains over 1 million square feet of floor space. Here are located the administrative, engineering, and program management offices and manufacturing facilities for forming, joining, and machining all types of aerospace structures. Modern laboratory and research facilities support the programs. Ryan's newest plant is this 160,000 square foot, 30-acre facility at Kearny Mesa, San Diego, 10 miles from company headquarters. Opened in early 1963, this plant is devoted to the assembly of electronic navigation equipment and Firebee jet target systems. Ryan designed and built the first jet drone over 15 years ago, and today produces more than all other companies combined for the Army, Navy, and Air Force. The third plant, also at Kearny Mesa, is the Ryan Electronics Engineering and Research Center. This is a 100,000 square foot facility located on a 21-acre site. Built in 1957, this complex contains one of the most modern electronic environmental test laboratories and bore site ranges in the nation. The first jet plane of the U.S. Navy was the Ryan FR-1 Fireball, a jet plus propeller plane that also pioneered the use of tricycle landing gear on carrier decks. Just after World War II, Ryan became deeply interested in vertical takeoff aircraft when it became clear that jet thrust in excess of aircraft weight would soon be available. We made the first piloted hovering flight in this test vehicle in 1953. This work led to the development of the world's first jet VTOL aircraft, the X-13 Vertijet for the Air Force. From this technological breakthrough and subsequent projects, Ryan has become a leader in the field of VSTOL aircraft engineering. Culminating a 10-year program, the X-13 demonstrated the good stability and maneuverability of jet reaction control of aircraft in vertical takeoffs and landings, transitions, hovering, and conventional flight. Ryan designed, built, and flight tested the Army VZ-3RY vertiplane aircraft, which can take off almost vertically, hover, and fly at extremely low speed. Using the deflected propeller slipstream for vertical lift, the vertiplane is flying at NASA's Ames Research Center, where it is used as a low-speed flight research aircraft. In 1955, the company began work on the Vertifan concept for a fan-in-wing VSTOL aircraft propulsion system. This led to the proposal, which was selected as the winner of the Army's design competition in 1961. A contract was awarded to General Electric, under which Ryan was designated to design and build two XB-5A lift fan VSTOL research aircraft. The mock-up illustrates the good compatibility between the lift fan propulsion system and a high-performance airframe configuration. Two XB-5A aircraft are being completed at the San Diego plant, where all systems are thoroughly checked out prior to flight testing at Edwards Air Force Base. Each plane is powered with two J-85 turbojets with a total thrust of only 5,300 pounds. The lift fans in the wings and fuselage augment this thrust by 300% to achieve vertical lift. Ryan is using its new three-dimensional VSTOL flight simulation laboratory to develop optimum piloting techniques for the XB-5A and other VSTOL aircraft. Surrounded by a 220-degree screen, the XB-5A pilot can take off and land vertically, hover, and fly at high speed with a realistic scene in view which instantly depicts the results of his control changes. A complex of computers simulates the aircraft characteristics and evaluates the actual XV-5A control system hardware. This simulator will support the flight test phases of the program. Ryan joined with Vaught and Hiller in a proposal which won the award in 1961 for the XC-142A tri-service VSTOL transport for the Department of Defense. The company is participating in the production of 5 tilt-wing aircraft under the $70 million contract. Ryan's task includes designing and fabricating the tail section, aft fuselage, and engine nacelles, and building the wings for all aircraft. The company is the leading producer of jet target systems. Here is the Ryan Firebee, which has accomplished over 5,000 successful flights to become the most thoroughly proved, reliable jet drone missile. The Firebee can be air or ground launched. It flies at Mach 0.96 and has flown as long as 84 minutes above 55,000 feet. The Firebee is compatible with all types of radar-seeking and infrared-type missiles. Kills are scored either by direct hits or when missiles pass within lethal range. After mission, Firebees are parachuted to land or sea and picked up by helicopter without the use of surface craft. Some targets have made over 25 flights before being expended. The tow bee is an inexpensive target, shown here mounted on the Firebee's wingtips, which is towed through a firing range by the Firebee to provide a bullseye for high-kill ground-to-air missiles. Tow bees are launched in the air and towed thousands of feet behind the Firebee. The Firebee can launch and tow multiple tow bees in sequence or formation on a single flight. Tow bees are jettisoned after use, and the Firebee is then parachuted down to Earth for retrieval. Almost every type of ground-to-air and air-to-air missile has been evaluated against low and high-altitude Firebees, flying under realistic combat conditions. A new concept, the flexible wing, shown in a wind tunnel, is spearheading one of the newest programs at Ryan. Based on an old idea, the flex wing consists of a membrane of flexible material and 2 leading edges and a keel. Early experiments showed that this device would provide greater lift for its weight than a rigid wing and more control and faster deployment than a parachute. Ryan built and test flew a manned flex wing test bed to obtain the necessary engineering data to apply this concept to a variety of military and space applications. More than 150 flights were made. The company is developing a family of tactical vehicles which use the flex wing, including this air cargo glider, which is being perfected for the U.S. Army. Towed by a helicopter, the flex wing glider can transport from 3 to 6 times as much weight in troops or cargo as the helicopter alone can carry. The glider can be picked up from any runway or prepared site. The air cargo glider tows with good stability and can be released from its tow line and guided for many miles into an off-site landing area. Under another Army contract, Ryan is developing a precision drop flex-wing glider, which can be pushed out of a small plane or helicopter to deliver several hundred pounds of high-priority cargo to a pinpoint site. It uses inflatable, rather than rigid, leading edges and keel. These members inflate after drop, then allow the cargo package to be guided by radio or automatic ground beacon to a landing area. A manned version is the individual drop glider, using the flex wing to bring troopers down to Earth. The second phase of testing has been completed. Here the flex wing could permit a man to select his landing site with a 3-to-1 glide ratio. For the Marine Corps, Ryan has adapted the flex wing to a small portable surveillance drone which can be carried and launched by 2 men. Carrying cameras or other sensing gear, the Flex B can take a look over the hill at an enemy and bring back a picture within minutes. The Flex B weighs only 70 pounds and needs no stabilization equipment in order to take clear photographs. It can fly 65 miles per hour and up to 10,000 feet in altitude. This is the Flex Wing Fleet, or utility vehicle, which Ryan is testing for the Army to provide a simple-to-fly air truck which can overfly obstacles to deliver troops or cargo. It can be expanded into large cargo versions. Ryan developed the first airborne navigation system to use continuous wave Doppler radar and has applied this electronic intelligence to many applications. By measuring the Doppler shift in energy reflected from land or sea, this system provides all necessary vectors of flight. Because it transmits and receives simultaneously, it is a lighter, simpler, more accurate radar system. These navigation sets are used in Navy and Army fixed-wing aircraft. Ryan developed the first radar hovering system for helicopters and is the only company producing this equipment for both U.S. and foreign helicopters. This equipment gave the helicopter all-weather capability. From Ryan Electronics, more than 2,500 navigation systems have been delivered for 33 different types of aircraft. Ryan has long been an efficient producer of airframe and engine components for other aerospace companies. More than 1,500 large aft fuselages for military aircraft have been built, including 700 of these units for KC-135 jet tanker transport for the Air Force. Ryan has also specialized in building engine pods and pylons for aircraft and designed and built these structures for 150 Douglas DC-8 jetliners. Explosive forming is a new production technique which the company has worked with for over 5 years and employed to manufacture more than 200 different production parts. For NASA, these huge gore sections are being produced by explosive forming and shipped to Huntsville, Alabama, where they are welded into domes which are 33 feet in diameter for the Saturn V rocket vehicles. The company is producing solar cell panels for the Mariner C Mars space probe, for transit satellites and other space vehicles from extremely lightweight alloys. Ryan designed and built the solar cell panels for the Mariner 2 Venus space probe, which powered its scientific and communication systems on its 180 million-mile flight. Saturn rocket launch vehicles are also equipped with Ryan Electronics radar altimeters, which signal the ejection of the booster and orbiting of the rocket. These altimeters can measure altitudes to 250 miles. The company's radar altimeters and velocity sensing systems will be aboard the Surveyor soft lunar landing spacecraft when they go to the moon. This equipment will operate from 10 miles above the moon's surface to touchdown and control the attitude and vertical velocity of the spacecraft. It's no coincidence that Ryan, a company with a long pioneering past, has geared its facilities to the space age future.